I don't know about you, but I'm constantly stunned by the ridiculous things you can find on the internet. And this has to be up there of one of the craziest things. That when you search party hat, you get a very nice happy birthday hat of a cat celebrating their birthday virtually during quarantine. Why is that a top result of that search? I don't know. But here we are, and it's going to turn into a great example for our cone example. So what we're trying to find is the surface area of a cone. And we did a similar thing with cylinders where we had to ask ourselves, what does the lateral surface area of a cylinder actually look like? So we had sliced up the side of that cone, cut it along that height, and unrolled it, and it turned out that the lateral surface area of a cylinder is just a rectangle. It's not quite as simple with a cone, but we're still able to see a shape that we recognize in some ways and figure out how that translates to our formula. So as you saw in the last question, it turns into a shape that looks like this. Hopefully you had a chance to try to describe that and figure out what in the world that shape is and how we can find information from that. So as it says in the top paragraph here, it turns out that the lateral surface area of a cone is a sector of a circle. And a sector of a circle is like you had a whole circle. So if we had extended this whole circle out, and then you cut a piece out of it by cutting along two of the radii. Radii is the plural of radius. So this is bounded by a radius here, and then a portion of that full circle. We call that an arc. So we're going to use information about sectors of circles to get at our formula for the lateral surface area of a cone. And it turns out that the formula for the area of a sector is 1/2 RL, where R is the radius and L is the arc length. Now, if you want a more thorough description of how we get that formula, feel free to ask me, and I can send you along a resource that gives a really good description of how that works. But we can use that formula to get at the formula for surface area of a cone using the actual dimensions of that cone. We just need to translate what the radius is and what the arc length is when we have our full rolled up cone. So the key to that is to take those two parts of the sector that are important, radius and arc length, and decide what would we call that when we roll it up. So first, given the net of the cone and the full cone, what part of the cone is A, the radius of the sector? So they're saying, what is this radius when we roll it up into a cone? So let's roll it up. And you'll notice that that line, those two radius lay on top of each other. And we now have a line extending from the vertex of the cone down to part of the circle. You can see it a little better here. Here's our cone with the circular base. Here was that radius, and it's going from the vertex down to that circle. So that's actually going to be the slant height of the cone, as I've labeled here. Not the height of the cone, because remember, the height of the cone goes from the center of our circular base to the vertex, but this goes from actually part of the circle to the vertex. So that'll be the slant height of the cone. Now, given the net of the cone and the full cone, what part of the cone is B? The length of the arc length of the sector. So this curved portion here. So again, let's roll it up and see what happens. And that curved portion all of a sudden has turned into our circular base. So what once was a curve is now the circumference of our base, right there. So we can fill that in, circumference of the base, and we can use that to now find the formula for the lateral surface area of a cone. So, like I said before, the formula for the area of a sector is 1/2 RL, where R is the radius of the sector, and L is the arc length of the sector. All we need to do is substitute in the information we just found and then simplify. So we're going to keep that 1/2, and what was R? R was the slant height of the cone. And in this paragraph, I've asked you to call the slant height of the cone S. So we're going to simply substitute in S. Now L is the arc length of the cone, and we said that that was the circumference of the base. So how do you find the circumference of a circle? Well, it's 2 pi r. So I've asked you to call the radius of our base, so the radius of this circle, little r. So we're going to write in for L 2 pi r. And now we can simplify this a little bit because 1/2 times 2 is just 1. So those can cancel off or go away, and we're left with S pi r, and I'm actually going to call it pi rs for a little clarity. And that is all we need to do here, is that lateral surface area of the cone is pi rs. And if we submit, you'll see that's exactly what we wanted. One key thing to note, that is not the full formula for the surface area of a cone. That is just the lateral surface area of the cone. If we wanted the full surface area, we have to include the area of the base, which is a circle, so that's just pi r squared. So we would get, in total, the surface area of the cone equals pi r squared for the area of that circle plus pi rs for the lateral surface area. And that's all you need to do for this problem.